Hi there, you're with Mr. Laurie, and this is part 11 of the linear and nonlinear relationships topic. Last lesson, we had our first look at polynomial graphs of the general type, that is, where the power was n. And we saw that if this power was even, our polynomial curves looked something like parabolas, and if this power was odd, they looked something like cubics. We then proceeded to move those up and down. Today, we're going to look at moving those side to side. Let's have a look at Desmos before we get started on some notes. For these examples, we're going to use the cubic y equals x cubed. So here is our standard cubic. Now, if we move it up by 3 places, this is adding 3 after the x cubed, like so. And if we want to move it down by 3 places, we would subtract 3, like that orange curve here. But the focus of this lesson is to look at what happens when we move it side to side. The first one we're going to look at is x minus 3 all cubed. Which direction do you think this will go? It moves to the right. You might have expected it to go to the left if you were thinking, hey, there's a negative there, and negative is to the left. But what we have to be aware of is that when we substitute in x equals 3, that gives us y equals 0. So we get the coordinate point 3, 0. This is our point 0, 0 from our original graph that has moved across 1, 2, 3 places to the right. If we want to move our original cubic to the left by 3 places, we will have x plus 3 in the brackets here. It is an x value of negative 3 that when we substitute it in here will give us a y value of 0. So if we want to move 0, 0 across 1, 2, 3 places, the equation will have the form x plus 3 all cubed. So really the sign, just like we've seen in previous lessons, makes our graph move in the opposite direction to what we might expect intuitively. Let's go back now and write a few notes, and we'll sketch some examples ourselves. Let's first of all write a definition for our standard polynomial curve y equals ax to the n. Regardless of the power of n, our standard polynomial curve always passes through the origin, through 0, 0. What if we have a minus in brackets? Well, based off what we just saw, we know that this is our standard curve moved to the right. Whatever r is, whether it's 3 like we looked at, or 4 or 5, it's by that many units that we move to the right. When we have a plus in our brackets, so y equals a outside of x plus r to the n, this is moving y equals ax to the n by r units to the left. Let's do 2 examples now where we will sketch 2 different curves. Remember that when we're sketching, we do not have to be super accurate like we would if we were graphing, but rather we just need to show the shape and any key features like intercepts. Alright, here's our first example. Sketch y equals 2 outside of x plus 1 to the 4th power. Now, if we just had 2x to the 4th power, we would look at the power and say, alright, this is an even power. And the 2 out the front, that coefficient, just stretches it up a little bit. But because it's an even power, it's going to look something like this, like a parabola. Okay, so I've done that one in yellow, but that's not what we have to sketch. We have to sketch this, which, based off the notes we've just written, has been moved horizontally. Because it's a plus in here, we have to move our 2x to the 4 1 unit to the left. So rather than going through 0, 0, it will now go through negative 1. We also have, as well as a different x-intercept, a y-intercept that we need to work out here. Remember, when working out a y-intercept, we need to set x equal to 0. So let's set x equal to 0 for our equation y equals 2 times x plus 1. We'll make that 0 plus 1 to the 4th power. 0 plus 1 is just 1, and 1 to the 4th power is 1. So 2 times 1 gives us 2. So this value here is 2. And so that red curve is our sketch. Alright, let's have a look at one more example. Sketch y equals negative a half outside of x minus 1 to the 5th power. Now once again, if we didn't have that minus 1, our standard curve would be represented by this. What does that look like? Let's do it in green. The power is odd, so we know it has a cubic shape. However, instead of going this way, we have a negative coefficient out the front, this negative half, which flips our cubic, it looks like a cubic, it flips our graph to look more like this. So that's what our more standard graph would look like. However, we have moved this graph one place to the right, okay, because there's a minus in there. So instead of going through 0, 0, it's now going to go through 1. And look something like this. Once again, we have a y-intercept to work out. So let's set x equal to 0 to find our y-intercept. Remember, we are substituting x equals 0 into our original equation. Instead of x minus 1, let's make it 0 minus 1 to the 5th power. Now 0 minus 1 is negative 1, and negative 1 to the 5th power stays as a negative. When we have negative a half times negative 1, we get positive a half. So our y-intercept here is a half. And that is our curve sketched with the relevant details. That finishes our lesson for today. Good luck with the exercise questions.